Hi, my name is Vincent, and today I'm going to talk about the rope swinging experiments. It's the last lab of Physics 2011, and in the introduction, I'm going to give the purpose of this lab, some models and fundamental principles, and the brief preview of the main results of my lab, and then I'll discuss about the details of my code, and then I'll discuss about the energy principle and some further questions. So the purpose of this lab is to experiment whether the energy principle is conserved, and I'm gonna use the Newton's second law, velocity update equations, and position update equations, and the energy principle using the system of mass, spring, and earth. And the result is that the system's total energy do follow and demonstrate the energy principle as delta E is approximately zero. And the physics main principle and formulas is that the system delta momentum is proportional to the proportion of time to the net force that applied, which is the Newton's second law, and maybe the system change in energy is the sum of the work done by the surroundings. And I'm gonna give the video of the world's largest rope swing. Maybe it's hard, and unfortunately, it's hard to track these data as in trackers. So maybe I'll give the only like the glow script coding, and this I assume that the ball mass, which is the human, but I use it as a ball, which is 70 kilograms, and the ball position is about minus 4600, and the ball vector is 000, as the length of the string is about 46 meters. And I'm going to use G as 9.8, and the spring constant is 11,000. Later, I will discuss why the spring in the rope here is discussed as a spring constant. And I'll use the kinetic equations is one half of ball mass plus the ball vector square uh, uh, multiplied by the ball vector square over square, and then the potential gravitational and the potential spring. I'll use the equations, and then I'll add up all of them to get the total energy, which is E, and then I'll get the gravitational of F is equals to minus mj, and the spring is minus ks and l hat, and then I'll get the total net force, which is F spring plus F gravity, and then I'll use that F net force to get the ball vector and ball position, and then later on, this is what I can like script it using the glow script, and then I can sketch, and you can see that. But still, there are some possible like human errors, such as the mass identifying the inaccuracy, and the numerical errors that the theory is not always accurate, because there can be like work surroundings, like in real life there can be drag force and a lot of stuff, but still, the energy principle satisfied, like no external force affected isolated system, and the change in energy is equal to zero. Like I have said, in real life, there may be other forces like drag that may make the total energy like delta E equals to it's smaller than zero and be negative. And what I want to discuss is why I assume that the rope is like a large spring. So ropes are like chains of spring, like connected dots together. So we can assume that it can be a very big string, because like big string and maybe a big spring, because like you can see that it's like a chains of spring like connected dots together on the left, on the right hand of you, and so you can assume that it's a very big spring. So that's all for my lab experiment this week. I hope you guys enjoy it. Thank you. And we all done with labs in physics 2211.